You know Faraday's law?
Faraday's law states that a change in magnetic flux in a coil induces a voltage.
You know Lenz's law?
Lenz's law states that the induced voltage in a coil from Faraday's law opposes the source voltage.
These are the theories behind inductors.
Resistors, capacitors, and inductors are the most important basic components in an electrical circuit. Let's focus on inductors. Generally, inductors are just coils of wire. It is a device in a circuit which momentarily stores energy in the form of a magnetic field. When the switch is closed in a circuit, it causes a current to flow through the coil, hence a change in current, which induces an electromotive force that produces a magnetic field surrounding the coil. This property is called inductance and can be found using this equation. The inductance is a measure of flux linkage. The greater the inductance, the greater the strength of the magnetic field. DC is a circuit with direct current, so current only flows in one direction. When an inductor is connected to a circuit with direct current, two processes occur, storing and decaying energy. Now let's have a look at RL circuits. RL circuits are just circuits containing resistors and inductors. To increase inductance in a circuit, we place inductors in series. To decrease inductance, we place inductors in parallel. In DC, there will be a transient interval while the voltages and currents in the inductors change. Let's look at an example. When analysing RL circuits, these are our main equations. This equation tells us the current at any time, this tells us the voltage, and this gives us the time constant. Now let's go through these three questions.
Before we do our calculations, let's first find the time constant, which is given by tau equals inductance over resistance. For our question, we get that the time constant is equal to 0.08 seconds.
A. When the switch is closed, current enters the circuit, but the inductor opposes this change, so at t equals 0, there is no current at all. Also, voltage is equal to the source voltage. B. At t equals infinity, we can use Ohm's law because after 5 time constants, the current has reached more than 99% of its final value. This gives us a value of 2 amps. At steady state, inductors can be replaced by a short circuit, therefore voltage is equal to 0. C. At time equals 2 time constants, we just use our equations and sub in all our known values. Note that it is asking for 2 time constants, not 2 seconds. Subbing all our values in, we get that current equals 1.79 amps and voltage equals 1.35 volts. When we sketch our waveform, we get this. As time approaches infinity, current approaches 2 amps. This is only between 0 and 5 time constants. For our voltage, we see that it starts at the maximum value, and as time approaches infinity, it approaches 0. As current flows through the inductor, it builds up a magnetic field through and around it. The more current, the stronger the magnetic field. This is how inductors store energy. The energy stored can be found using this equation. For our example, the energy stored in our inductor is equal to 0.8 joules. This is the final energy stored.
Inductors are required in many electronic devices and are commonly used in TVs, transceivers, and radios.
Now.
You.
No.
Down.
Inductors.
And
See. Thanks for
watching.